Marc Cluet, and he's going to talk about a metadata ocean in Puppet and Chef. And I'm quite curious to see what he has to say, so again, I'll just shut up.
Maybe I can.
Right, hello everyone. I couldn't make any of the talks before, but just queuing outside. So, who I am Marc Cluet. I've been a sysadmin for 16 years. Done a bit of everything from racking modems to setting up networks to going to customer houses and telling how the internet works. I was working at Chemical before, where I was one of the founders of Juju and Mass. And I'm now running a DevOps engineering team in Rackspace, in which we try to help with configuration management and all the things. I like DevOps, and I play it in my free time and walks in the beach. So, Rackspace is the second biggest public cloud in the world. It's quite a big hosting company founded in 1998, and we're quite proud to say we are the OpenStack project co-founders with NASA. So what is metadata? Let's go back to the basics, right? This is kind of a metadata joke in a certain way. But in reality, metadata is data about data. So it's a data you use to define what data is. There's two types of metadata, right? There's structural metadata, which would be, for example, XML or HTML, in which you use data to define data. Or descriptive metadata, which is the one that we're most interested about in this talk. It would be the kind of data that defines a unique thing like a server. So all the unique parameters that make this server a beautiful thing. So how does metadata work in Chef? Metadata in Chef is compiled on the client execution time, and this is a very small detail, but it's something that will bite you very hard if you don't have in mind. Metadata is always compiled at the end of the execution time, and it's always stored in a JSON dictionary. So anytime that you use Chef and you do a knife edit node, you're actually editing the JSON dictionary that belongs to that server. So where you can add metadata in Chef? You can add it in the attribute files of your kubebooks. You can add it in the node itself, which is something that you shouldn't do, but I've done 1,000 times and regretted afterwards. You can add it in your recipes as well, in your environment set, if that metadata is pertinent to the environment, or in the role itself, if it belongs to the role. And the good thing about Chef is that all these variables in metadata can be overwritten at certain points in time, but the amount of exceptions for that is quite complex. So I've just added the chart here straight from Ops code documentation to see how complicated that can get. So you can define the same variable of metadata in 50 different places. So in Puppet, metadata is slightly different. So as you know, Puppet always compiles metadata on the server in execution time. So that's sometimes a good thing, but then the Puppet master starts suffering from that when you have a lot of servers. Metadata variables can be reassigned, which is something that I would say it's a deliberate choice, but it makes your script books and the way you define metadata quite tricky, because you can't overwrite any kind of variables. And it's always defined like that, or with a class before the introduce any comments. So where you can add metadata in Puppet? You can add it in your classes, you can add it in your nodes, or you can add it in the top scope of your Puppet installation if you have a Puppet master. So variables and metadata in general in Puppet is very tricky, because the scoping in Puppet has been changing with time. So what we all used to do is to put all metadata in the node definition. You define $server type equal web server, and you were happy with that. But that's now a bad thing to do, because the scoping, I said, in Puppet gets very complex, and this starts to look to me a little bit like Java, to be honest. It's very complicated, very difficult, and wherever you put the variable, you have to have in mind all the context that it has, which makes you, I would say, quite wary of where you put that definition. So REPNR came to the rescue. See, he's the guy who did mCollective and the guy who did higher as well. So he did higher as a Puppet plugin, And in there you can define all your metadata in a very structured way. It's all based on YAML or JSON dictionaries, and it looks very good. You can actually overwrite values, you can separate literally your variables in the metadata outside your execution field, which would be your models and your recipes. So this, for example, would be a config file in Cohere, and you can see especially the hierarchy section, which is very interesting, in which you can actually define how these metadata and these variables will override on each other when you execute. So, as everything, there's bad metadata practices, so you can play with the Wheel of Fortune of metadata madness. So in Chef, what kind of things you shouldn't do in Chef? Chef is a very powerful tool, as it's called, but since you can overwrite definitions and no definitions of metadata pretty much everywhere, it can get very tricky, and you can actually put metadata in every single point. You can put it in the top scope, you can put it in the environment, or you can put it in the node itself. So at the end of the day, when you execute, you don't really know where variables are coming from, and they start populating your node dictionary, and that gets incredibly messy. So you need to keep consistency of that, and make sure that whatever variables, whatever metadata you define, it needs to be in the right scope, right? So if that belongs to the environment, you need to put it in environment 1. If that belongs to the class 1, etc., etc. If you don't do otherwise, you can start having things like I did, that I had an environment, then a function, then a class, and I could touch metadata in any of those 3. And at the end, I had the metadata divided in 3 different places, and I didn't even know where I was looking. I was grabbing my JSON definitions like crazy. Also, the other thing that we always forget is that when you remove a cookbook or a class from a server, all the metadata that it declares stays behind. So all that is inside the JSON dictionary. So you need to be very careful, because you can make those dictionaries grow and grow very silly and make your executions very slow. And also the other thing that we've done at some point, is to assign metadata directly inside the cookbook. Just go $node name of variable equals something, and then suddenly your node variables start changing, and you don't know where that comes from. So that would be slightly madness, but that is always the thing that we do when we're under pressure. So what kind of things you shouldn't do in Puppet? In Puppet, sending a metadata straight into a class without defining a default variable for that is always a bad thing to do. So that means having the metadata inside your class itself, in the middle of that, and you don't know where that variable comes from, what's the scope. So it's always good to, when you define your class, to have the list of variables as the definition of the class. You have default values for that. So then you can override those in the definition of the node, and you know exactly where all of your variables are. Also, you shouldn't assign variables inside NoSPP, which is one thing that I've been very guilty about myself. That was the usual before, but right now, the scoping problems that NoSPP has are very, very crazy. So they are not global scope, they are not local scope, it's something in between. And as I said, when you run Puppet lint or you run Cucumber, it always complains about that. And also, global variables should go inside PP. So make sure that if you're running on a Puppet master and not on a headless operation, you should define those variables then. So what are the good behaviors that we have? Because as there's bad behaviors, there's always good behaviors, right? So for me, the most important behavior is separate variables from execution, right? Because your variables and your metadata is your brain, where the execution and the definitions are your muscle. So you shouldn't be merging your brain with your muscle, because that always creates trouble. And having a high abstraction of your variables, being very clear about it, so say being a better programmer than I am personally makes all of this a lot easier. So the good behavior, as I said, would be declaring global, then that being modifiable by the environment, and then that at the same time being modifiable by the node. And this problem just gets bigger, right? Because you have metadata in just one thing, as Chef or Puppet, but then you have more players in the field. You have your provisioners, like Cloud Init, like Cobbler for hardware, or like Juju. And those provisioners also have a set of metadata. So let's say in this case that you have a provisioner, which would be Cloud Init, and a config management with Puppet, and both of them like to define what a doc is. and they define it in completely different ways. So the problem is who is right on that? Because again, you have the brain with the muscle all together. So what happens is that you pretty much end up punching yourself in the face, and that's not a good thing to happen, right? So this is what I call the metadata brain split problem. It's a very hard problem to have, and it starts kicking you very early when you do your implementations. And not also that, there's also another layer of complexity of this, because the system view varies as well, because the system gives you another set of metadata, like CPU, amount of memory, etc. And it's not the same, the kind of stuff that the buyer says to you, and the kind of stuff that cover will see at booting time, than the kind of stuff that factor or high will see when they are at user level execution. So that also adds some randomness to the whole equation. So what would be some possible solutions for this? I would say one solution would be, for example, creating a central database using something very fast, like Redis or MongoDB, if you like replication delays, or MySQL. Maybe writing some metadata translators, so have that central entity and translate that back to every kind of metadata that you need in every single provider and execution conflict management that you need. The problem with this is that this creates a new single point of failure. So this is pretty much like XKCD, right? You have 14 standards. You say, hey, I found a solution for everything. I'll just create a new one. And then you have 15 standards competing against one each other, which again, sucks. So another solution would be, which is something that I tried to do with Juju, I wasn't too successful on that, is to try to scope variables from top of the chain. So whenever you execute, since this is a chain of eventuality and one thing passes to the other, make sure that all the metadata from the first one gets visible from the second execution, gets visible from the third execution. So whatever you have, whatever application, will see all the metadata and all the variables from the previous ones, which would be very clean, but again, that would require coordination between different applications and different companies that are competing one against each other. That's pretty much it. Any questions you may have from metadata? Go for it. So the question is, how do you encrypt metadata? Because he knows there's some libraries in Puppet that can do it. The answer is very difficult. I wrote a plugin for Cloud Init in order to do that, because Cloud Init itself, all the metadata that it injects into the cloud, it's all plain text, and it's completely unencrypted. Now the problem is the chicken and egg situation, in which what's first? It is first the machine, it is first the provisioner, it is first Puppet, or the Puppet certificate. So for the provisioners, the situation is a catch-22. There's no real solution. I would say the best thing you can do is to create some PSK and hope that nobody knows it. And for Puppet, for example, or mCollective, I wrote a plugin for mCollective that what it did is to pre-sign a PSK into Puppet to know that the nodes were coming up, so Puppet knew which ones to sign, so it didn't sign anything that it didn't know about, which is as secure as you can get. But again, it's a catch-22, you need to put a PSK in the middle and the NSA will know about it. It's just crazy. So, any other questions? Yeah. So the question is, there's bad ways to solve this split brain problem. If there's any good solution, the answer is not really. Those are the ones that I think that are closer to the solution, but all of them have caveats and all of them have problems as well. So I would say at the end it's just a question of what's the best for your platform. Are you able to inject $10,000 into making this happen in your company, or do you get, as most of us do, $100 and a thank you? So it's a question of how much money can you inject into this and how important is that for you. Any questions? Yeah. So So the question is if I'm asking for a central database that is completely agnostic for metadata, and for example, Cluet tried to do that in the past, and yes, that's what I would like to see personally. But as I said, what I would like to see and my hopes are go against what the industry thinks. So everybody thinks that they solve this solution with their own platform and their own product. As I said, it's just like the exclusivity coming. There's just more and more standards to go. Yes? That's it. Thank you very much.
Hello. Thanks, Marc.
Sorry. Put some more out, and then some more in.
Hello.
Hey, how you feeling?
Thanks for we good. Yeah, the last 24 hours. I just got
Hello, is Corey Quinn in the room? I had a feeling it was. I had a feeling it was.
All right.
Yeah, there's a few more empty seats. Yeah, if everybody over there can move into the middle. We have people waiting outside. Let's see, one empty seat here. There's maybe like 5 or 6 over there.
Probably one more. Thanks.
every year. This room is twice the size. And of course, everyone that walks in the room tells us we actually get a bigger room next year. We have no control over it. They get a sign. We're still full over here, right, Doc? Still full?
I think
I'm bummed I missed Sean and Mike's talk. Mike was told like 3 days ago. Oh yeah, you can do that. I mean, he's great. Yeah, it was a good song. Are we recording this one? Yeah, okay. Excellent. I think they might even be streaming. Not 100% on that, but they're definitely being recorded. Yeah.
My Oxford ID selfie. I have one just as I showed up and I realized I don't have anything truck related.
Actually, that's awesome. You have like 13 minutes.
Good time.
Room's full anyway, so yeah. So you can take it nice and easy. Very, very slow.
Why not?
Alright, so next up is Corey Quinn. He's going to introduce us to SaltStack. Again, I'm quite interested because I literally have not seen anything about Salt. So it's interesting.
That's right.
Yeah.
There we go. Oh, perfect. I won't need all of it. They told me 25 minutes, so
Yeah.
I'm trying to be under that. We'll pay it forward. Okay, before I dive into this, can I see a show of hands of who's ever run Salt before? Okay, roughly half of the room. That's quite reasonable. The reason I ask is just because whenever I give these talks, it seems that the audience is sort of varied as far as their level of experience, level of exposure. Some people have never even heard of it before and just wanted a seat in a room they could actually get into. Other people have been contributing for it for years and just want to ask fun questions at the end. It's an interesting phase. First off, I'd like to apologize a little bit. They wound up cutting times on these presentations, so I know I promised a demo in the write-up, but unfortunately we're not going to be able to deliver that at this point. But we do what we can. Sorry for the false advertising on this. Okay, so who am I? To answer the question initially, I do not work for SaltStack, although Dave in the corner does, who will be fact-checking me on everything I say that's stupid, which is most things. I'm a technical consultant at Taos, a company based out of the greater Bay Area in California. I'm also staff for the Freenode IRC network in my spare time, where we contribute to things like Fosdem. And I was number 15 to contribute to SALT, which is kind of awesome that we're above 500 now. It lets me talk about things I remember way back when. At the moment, I'm currently packaging it for Homebrew for Mac, but I spent an interesting year as the Ubuntu packager as well. And didn't make it onto the slide, but 3 days ago, I wound up passing the newly created SaltStack Certified Engineering certification. Fantastic. That went on the resume. Oh, yes. Okay, so what is Salt? This is not going to be an in-depth explanation of everything that Salt does, because at this point, the project has grown and blossomed in such a way that this would take several hours to go through, and frankly, no one has that kind of attention span, least of all me. We're going to be relatively high level, an overview of what it does, and I'm going to come back toward the end with a couple of the high-level features that Salt does that you may not have heard of before. So what we're going to do is we're going to start with the basics of what Salt actually is. It's configuration management, meaning remote execution. And as far as what those are, let's break them down one at a time. Configuration management, as I see it, really consists of 5 primitives. And there's no configuration management system out there that I'm aware of that doesn't do these 5 things. Once you wind up achieving all of these, you effectively have control of the node. And that's not particularly difficult these days, and it's not hugely interesting. Everyone does it, but the question is what else is actually out there? Endless studies have shown that anywhere between 4 to 10% of companies out there are running a configuration management system that was not developed in-house. So far and away, the most common thing people are still using in 2014 is SSH in a Fosdem, or something built around parse. This is somewhat unfortunate, given that people are reinventing an awful lot of wheels, and it doesn't necessarily have to be there. Okay, now that we've covered what your configuration management is, there's really only one primitive for remote execution, which is to do the thing over there. You can think of it like a flamethrower. Basically, I want to set that thing over there on fire. Done. Problem solved. The nice thing about Salt is that it leverages a message bus to do this, so you can do the thing everywhere, or on a very clearly defined subset of things. And it winds up, so you're not winding up doing this in series. You're actually going parallel throughout your entire environment. And at this point, it does scale to tens of thousands of nodes. And this has been tested in a number of environments. LinkedIn, for example, is currently running this at that scale. It's kind of an interesting thing to see. So one of the things that I really just dive into Salt, what makes it a little bit interesting compared to other contenders in this space, is the simplicity of the configuration. It doesn't have anything approaching a DSL, it's pure YAML at this point. In fact, this is not an abbreviated example, this is actually taken out of running a production environment. It starts off by defining, all this does is handles HTTPD. Unlike a lot of entrants in this space, one thing that's probably worth pointing out is that it does have a dependency model that goes top to bottom, which is nice. It doesn't randomly allocate that. That was actually added in relatively recent generations. So it starts off with obviously defining that the package has to be installed. It does that. It then winds up managing the file itself, obviously the configuration file, and it gives it a source. That source can be a static file on disk. It can also be templated out with Jinja, which we're not going to dive too heavily into. And one thing that I want to point out as well is that it then defines a service as running. And I forgot to call them there. At that point, it watches the file, so it will restart the service when that file changes. And lastly, what I want to point out that makes this a little bit interesting is the require statement at the end. If it goes top to bottom, then why would I bother to put in a require there? Simply put, because if I don't require it and something goes wrong putting that configuration file into place, it'll just continue iterating through it. If that require fails, it will not start the service, which actually winds up providing a nice failsafe. Picture a scenario of adding a load balancer, adding a web server to a load balancer, where you don't actually have static assets in place on the web server. That's how you tend to have embarrassing production outages. Okay, one other interesting thing as well that takes it a bit beyond this is something called the event reactor system. And this is where Salt really winds up shining. You just saw the dependency model that I laid out. That was not a random event. Because what this does is effectively does the same thing. If a file changes, restart the service. If this, then that. What the event reactor winds up buying us is it gives us that same type of dependency model, only we're no longer talking about a single node. We're talking about things like if this web server comes up, then add it to the load balancer. If that server load exceeds a certain threshold, remove it from the load balancer. You essentially wind up being able to map dependencies and have cause and effect relationships throughout your entire environment. This is something that traditional systems, particularly our old friend rsync and SSH, tend not to do as well as you would hope. It's environmental orchestration, and that's sort of a new and interesting thing. Something else that's been included in Salt for a while as well is called Salt Vert. It's actually a built-in part of Salt. It's not a separate project. And this buys us a few interesting things. Specifically, it lets us deploy virtual machines. Today, KVM is the number one, so it's the only first-class citizen, although support for LXC is coming up, as well as Zen. At SaltConf 3 days ago, we were also given an interesting presentation on how it integrates well with Docker, which was presented here 2 talks ago. It's really turning into an interesting space. What this winds up doing is this adds a great abstraction layer on the business of instantiating and running VMs. Being able to precede the image with Salt's configuration management system means you can decide to spin up a VM on a particular hypervisor in your environment, and it comes up automatically populated, which is rather nice. But at that point, that's a neat idea, but it also starts speaking to something that's a little bit higher level, and that's called Salt Cloud. What this does is it winds up provisioning into both private and public clouds. Yes, welcome to the cloud. It's where we DevOps. In the next Salt release, this is actually going to be merged in as well as a component of Salt, no longer a separate project. That's already been done in the current release candidate, which we're expecting to release this coming week. And what this serves as is an interface to cloud providers, which is fairly comprehensive at this point. And what this does is it's not just a list of, ooh, look at all the things that we support, but this represents something that we tend to be driving towards as an industry, whether we realize it or not. For example, as a consultant, I wind up speaking to a number of companies that are doing migrations either into or out of AWS, moving it in because of the rapid provisioning and instantiation of environments, and moving out because holy crap is it expensive to do it at scale. When you can build a data center for what you're spending in Amazon in less than 3 months, it's really time to consider maybe doing something else. The problem is, and the reason I pick on Amazon for this, is that they are obviously the market leader with a lot of very interesting platform-specific services. Take RDS, their database service. That's great, but no one else really offers a database service at that same layer. So what this really speaks to is what it's going to take going forward as we start building out cloud environments that are truly portable, is that we also have to wind up building services as well, rather than relying on the ones that providers give to us. If you, rather than going with RDS potentially, you instead define some form of, you design a state within Salt or whatever you're using. This doesn't need to be Salt specific. And you wind up spinning up your database service inside of a container. If you wind up restricting your interaction with AWS or any other cloud that you're using to basic primitives, stand up an instance, spin down an instance, add it to a load balancing layer, and then have everything else defined in terms of what happens once those instances are up, you've bought yourself tremendous portability. Obviously, it does wind up being sort of a test case. You have to figure out how to scale it sooner rather than later, as opposed to once you try to move off and then reinvent the wheel, it's already bought you a tremendous amount of technical debt. This is sort of becoming a new best practice in the industry that some of us haven't quite fully realized yet until it winds up smacking us on the face a couple of times. As a consultant, I get to see it a lot, but people who are embedded in various shops either are just starting to realize it and don't have the luxury of moving on to a new project in 6 months so they can forget and do it better next time. So it's definitely worth calling out as one of those dependencies. If you manage to target common APIs, your migrations wind up hurting a lot less. As I mentioned earlier, that we're definitely looking at a point now where there's a transition going on in the configuration management state, the configuration management space. Node management has been relatively solid for a number of years. It started with CF Engine, then Puppet and Chef wound up addressing that. But now with things that are coming up like Salt and Ansible, we're really starting to talk a little bit more about the ability to manage entire environments. When you start thinking more holistically and being able to interface between different services, that really becomes a powerful thing, and it drives towards a new way of looking at your environment. So the real fun part about this is, I've talked a little bit about what's coming, but specific to Salt, what's next? What is it that we're looking to wind up doing? It's a hard question to answer because probably in the time I've been giving this talk, 3 new pull requests have come in, each with a new feature. To say that Salt moves rapidly is being a little bit understating the case. There's currently a project in the works that's going to significantly shore up the integration with Docker. It's already working in an early alpha stage, but it's not there yet. And there's a separate project that I want to go into very slightly that's before I dive into this, one thing that's interesting about Salt today is that it's built on top of 0MQ, which serves as the transport layer. Very soon, that's going to be replaced with a transport that by default uses UDP, could also be TCP as well. It's currently in development and is just announced this week, called Rate. This is sort of new. This hasn't really hit the configuration management space, so you're pretty much seeing it here first. Hooray! Secrets. What this does is it makes the communication protocol very pluggable. You can drop in 0MQ, which is there today. You can use salt SSH and run the whole thing agentless and just use our old friend SSH. But now you can also drop in this as well, which is sort of forcing a refactor of how things have been addressed before, which means other transport layers are available in the future. What this does is it means that your actual queues wind up, you have multiple queues per socket, which allows for things like packet prioritization, and it scales up rapidly. This very realistically takes Salt from being able to scale from tens of thousands of nodes to hundreds of thousands of nodes, which is turning into something relatively interesting. Not a lot of companies are at that space yet, but it's coming, and it's really neat to be able to see it. At this point, it also winds up kicking encryption down to the socket layer, which is rather convenient, because at that point, encryption becomes pluggable as well. The value of that is that it winds up using published crypto libraries, which means that at this point, Salt can actually get out of handling the crypto space itself, which in the past has led to some interesting challenges, as I'm sure some of you have heard. At this point, this has been my talk, and if you're this is something I've been riveted by. It's something I've been talking about for over a couple of years now, and it's something that I really hope that people wind up seeing a bit more of. The next talk, just so you're all aware, is David Ludercourt from Puppet Labs, who's going to talk about a project that's near and dear to my heart, provisioning with Razor. So it's definitely worth sticking around if you're on the fence about it. Are there any questions I can answer for anyone? Yes? To whom? Never heard of it. So your guess is as good as mine. Sorry. Yes?
Well, Salt Stack goes a bit into the waters of managing the application there. The lack of separation there. You know, we have all these new tools that actually make it very easy to separate orchestrate the application there. But Salt Stack is kind of into the waters.
You're right, it is. What's interesting is the way that you can actually wind up structuring your state trees. It can lead to a very clear separation. There are a number of shops as well today that are using Salt to orchestrate existing Puppet or Chef environments, to use existing other systems entirely for management of nodes, but then turning to Salt for the ability to essentially orchestrate those environments. At its very basic level, it acts as an incredibly powerful replacement for SSH in a form. If all you're ever using it for is to kick off runs of your Puppet nodes, just so you don't wind up having everything fire at once and destroy your Puppet master, that alone is sometimes worth looking into. Does that answer your question?
Kind of, yes.
Okay. Anyone else at this point? Perfect. Thank you all very much for your time.
So we have like 15 more minutes. If you have something of like a demo or something.
Not prepared at this point. I was still 25 minutes at the most.
Okay.
Sorry.
Yeah, no problem. In that case, we'll
The interpretive dance? Wow!
climb on the table and. All right, then I guess we'll have a little break because otherwise we're going to be too much ahead of the schedule. So we'll just take a 15-minute break and then we'll continue with the next.